Pre-statistics. Rational exponents part 2. Lesson objective. Simplify expressions that have rational exponents using a calculator. If you recall in the previous video, we looked at problems where we took a number and we raised it to a 1 over n power. So for this example, 81 to the 1/2 power. That means what number do I square to get 81? Well, that number is 9, because 9 squared is 81. So whenever we see an exponent of 1/2, that is equivalent to the square root. Square root of 81 is 9. So a question you may ask is, well, what is 81 raised to the 3 over 2 power? Well, we will answer that in this video. Let's look at another illustration. 125 raised to the 1/3 power. So this is asking, what number do I cube to get 125? Well, that number is 5, because 5 cubed is 125. So 125 raised to the 1/3 power is the same thing as the cube root of 125. So again, well, what is 125 raised to the 2/3 power? Well, we will answer that in this video. Definition. For counting numbers m and n, where n does not equal 1 and b is a real number for which b raised to the 1 over n is a real number, we have this formula. b raised to the m divided by n power. This is equal to b raised to the 1 over n power raised to the m power, or b to the m power raised to 1 over n power. Now this looks very complicated, but really it's not that bad. If we have a negative m divided by n, then we still follow the same rules as before. If you have a negative exponent, if it's in the numerator, you send it to the denominator. If it's in the denominator, you send it to the numerator, and you change the sign. A power of the form b to the m divided by n power, or b to the negative m divided by n power, is said to have a rational exponent. So this is just a fancy way of saying we have exponents that are fractions, rational numbers. So if you recall, the number that's inside the radical is called a radicand. This is called the radical symbol, and then this number here is what we call the index. Now if you don't see an index, it's understood to be a 2. So for this class, we will let the calculator compute these values for us. So we have a square root key on the calculator, but what about numbers who have a different index than a 2? Is there an n index key? And the answer is yes. If we considered the 4th root of 10,000, now it turns out that 10,000 is equal to 10 raised to the 4th power. So if I compute this, 10 to the 4th power, and if I take the 4th root of that, the power and the index cancel. I should get back 10. But let's see that using the calculator. So what you have to do first is put the index. In this case, our index is 4. Then you want to hit the math key. Go down to number 5, where it's this symbol. Hit enter, and then type in the radicand, in this case, which is 10,000. Hit enter, and you get back 10. Now this is also the same thing as taking 10,000 and raising it to the 1/4 power. You will get the same answer, 10. And as I said before, 10 to the 4th raised to the 1/4 power. 4 times 1/4 is 1. 10 to the 1st power is 10. So it works. Let's do some examples. Example 2. Simplify 25 raised to the 3 over 2 power. Number 2, negative 27 raised to the 2/3 power. Number 3, 32 raised to the negative 2/5 power. And number 4, negative 8 raised to the negative 5/3 power. Solution. Number 1, 25 raised to the 3 over 2 power is the same thing as 25 raised to the 1/2 power, and then that number being raised to the 3rd power. Well, we know this is 5, so 5 cubed will be 125. Number 2, negative 27 raised to the 2/3 power can be thought of as negative 27 raised to the 1/3 power, and then that number being squared. Well, negative 27 to the 1/3 power means what number do I cube to get negative 27? Well, that's negative 3. So negative 3 squared is negative 3 times negative 3, which is a positive 9. Number 3, 32 raised to the negative 2/5 power. Well, we first have to make the exponent positive. So since it's in the numerator, we send it to the denominator. The numerator will be a 1. Next, this is equal to 32 to the 1/5 power. So we need to think, what number do I raise to a power of 5 to give me 32? Well, that turns out to be 2. So we have 1 over 2 raised to the 2 power. And again, that's simply 1/4. Number 4, negative 8 raised to negative 5/3 power. We first want to make the exponent positive, so we send this down to the denominator. Now notice, this still stays a negative 8. The base is negative, but now the exponent is positive. Now that is equal to negative 8 to the 1/3 power, all raised to the 5th power. Negative 8 to the 1/3 power is negative 2. So we have 1 over negative 2 to the 5th power, which is a negative 1 over 32. Now again, for this class, we will let the graphing calculator compute these values for us. So using the graphing calculator, if I take 25 and raise it to the 3 over 2 power, I get 125. Negative 27 raised to the 2/3 power is 9. 32 raised to the negative 2/5 power is 0.25, or 1/4. And the last one, negative 8 raised to the 5/3 power is negative 32. Again, be very careful. If you leave off the parenthesis in your rational exponent, you will get a wrong answer. And if your base is negative, make sure you use parentheses around the base. So the correct answer is negative 32. This value is incorrect. Example 3. For f of x equals 64 to the x power, g of x equals 3 times 16 to the x power, and h of x equals negative 5 times 9 to the x power. Find the following. Number 1, f of 2/3, 2, g of 3/4, and 3, h of negative 1/2. Solution. Number 1, f of 2/3 will give us 64 raised to the 2/3 power, and that's equal to 64 to the 1/3 power quantity squared. 64 to the 1/3 power is 4, and 4 squared is 16. So for this function, an input of 2/3 has an output of 16. Number 2, g of 3/4 will be 3 times 16 raised to the 3/4 power. Split the exponent up first, 16 to the 1/4, then cubed, then multiplied by 3. 16 to the 1/4 is 2. Next we cube it and we get 8. And lastly we multiply and we get 24. So an input of 3/4 for this function has an output of 24. Number 3, h of negative 1/2 gives me negative 5 times 9 to the negative 1/2 power. We first have to make the exponent positive, so it goes to the denominator. Negative 5 stays in the numerator. 9 to the 1/2 power is 3, so our final answer is negative 5 divided by 3. Using the graphing calculator, 64 raised to the 2/3 power is 16. 3 times 16 to the 3/4 power is 24. And lastly, negative 5 times 9 to the negative 1/2 power is negative 1.6 repeating, But if I change that to a fraction, I get negative 5 over 3. It checks. So let's summarize. When we have a base that is raised to a fraction, a rational number, the denominator is the index, the numerator is the power, is the exponent of the number that will be in the radicand. So the denominator is the index and the numerator is the exponent of the number and the radicand. Thanks for watching.